Hi everybody, welcome back to this course on internet technologies. So in this video, we will get to know about some client server concepts. So in computer networking, most applications follow the client server model. It's a fundamental design where one program called the server continuously runs waiting to offer services while other program called the client sends requests to those services. Think of it like a restaurant. The server is like a waiter standing by until a customer arrives. The client is the customer placing an order. The relationship is asymmetrical. The server doesn't go out looking for clients, it waits. The client initiates the communication whenever it needs something. This model is used everywhere from web browsing and emails to database systems and file transfers. Let's walk through how this works in practice. A server application starts on a system. It initializes resources like ports and memory, then enters a sleep state, waiting for a connection request. When a client program sends a request, the server wakes up, processes the request, sends back a response, and then returns to sleep, waiting for the next request. This is again an asymmetrical relationship. The server never initiates, it only responds. Also, remember the client and server could be running on the same machine, different machines on a local network, or across the internet. Regardless of location, the working model stays the same. Now, one way to design a server is as an iterative server. In this model, a single server instance handles one client request at a time. If another client tries to connect, it waits until the server finishes the current task. This works well when each request takes a predictable short amount of time, like downloading a file or fetching emails. It's simple to implement, it uses less system resources, but it cannot handle many clients simultaneously. If the load increases or one request takes too long, other clients have to wait. Now, when client requests can take unpredictable amount of time, like in a chat app or web server, we use concurrent servers. Here, when a client connects, the server creates a new process or thread to handle that client, while the main server continues listening for new connections. This is often done using system calls like fork in Unix or using threads in modern languages. It allows the server to handle multiple clients simultaneously, ensuring one slow client doesn't block others. The trade-off is that it uses more resources than an iterative server, but it's essential for interactive and real-time applications. When a client and server communicate, it happens over a network stack. At the transport layer, applications use either TCP or UDP. TCP is reliable and connection oriented, great for applications where data order and integrity matter, like web browsing or file transfers. UDP is faster but connectionless, used for things like streaming or gaming. Below that, the data link layer might be Ethernet for Wi-Fi. The network layer uses IP to route packets. The application layer interacts with these lower layers through something called the Berkeley socket interface, which acts as a bridge between network protocols and the application. Each layer has a specific role, and together they enable seamless, structured communication between client and server. To enable this communication, both the client and server create a socket, that is an endpoint for data exchange. Each socket represents a half association, that is just one side of the connection. When a client connects to a server, these two halves combine to form a full association, allowing data to flow between them. On the server side, it creates a socket, binds it to a specific IP address and port number, then it listens for incoming connections. On the client side, it creates its own socket, connects to the server's IP and port. Once connected, both sides can send and receive data over this connection using either TCP or UDP depending on the application's need. This is the basic foundation for nearly every networked application you use today. And with that, we've come to the end of this lesson. The next lesson will be all about basic application layer protocols like DNS, Telnet, and FTP. So, thank you for joining in, and I'll see you next time.